students, and welcome back to another video. In today's video, we will be factoring by grouping, and at the end of this video, you should be able to factor a 4-term polynomial or algebraic expression by grouping. Now, here are the steps that we will be using in today's practice lesson. Step 1. Group terms with common factors, ensuring that the first 2 terms have a common factor and the last 2 terms have a common factor. Step 2. For each pair, factor out the highest common factor. And in step 3, we're going to check to see if we have produced a common binomial factor. If we have not produced a common binomial factor, we need to go back to step 1, rearrange our polynomial, ensuring that the first 2 terms have a common factor and the last 2 terms have a common factor. Then factor out the highest common factor, and if it still doesn't work after that, then we can say that the polynomial cannot be factorized by grouping. Now, might sound like gibberish so far, but I guess by the time we start practicing, it's going to make sense. So in our first example, factorize the following algebraic expression: ax plus ay plus qx plus qy. Now our first step is we're going to look for the common factor. So this has a in it. So we have an a here and an a here. Alright? And over here, so we have a q and a q. So the first 2 terms have a common factor and the last 2 terms have a common factor. So the common factor in the first 2 terms is what? A done. So we could factor out a and we're left with x plus y. Then in the second term, we have what is common? Q. So I factor out my q and I'm left with q into qx and q into qy gives me y. Now in case you're uncertain of how to factorize using the highest common factor, the link will be in your description. So hence, here we have what is called a common binomial. So we can factor out these binomials. So one, that would be x plus y. And then our other factor now is going to be on the outside. So we have a plus q. Now to test our answers, we could go ahead and multiply them. Multiply both binomials and we'll get back our polynomial ax plus ay plus qx plus qy. In our next example, we have 3ax, 6ay plus bx minus 2by. Now, let us see if we can identify common factors in the first 2 terms and common factors in the last 2 terms. So in our first 2 terms, we have what here? We have 3a and we have 6a. So 3a can go into 6a. So okay, so those have some common factors. Then over here we have bx and we have 2by. So we have b common to both. So let us now use factorization by the highest common factor and see if we end up with a common binomial. So in this first 2 terms, I can factor out 3a. So 3a into 3ax gives us x. Then 3a into minus 6ay gives us minus 2y. Then our next common factor here, or highest common factor here, is b. So plus b, open bracket, b into bx goes x times b into negative 2by. We're left with what now? Minus 2y. Ding, 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 ding. We have a common binomial. Hence, our factors are x minus 2y, because we're factoring out one of our binomials, and our other factor is going to be on the outside, which is 3a plus b. So 3a plus b, and if we were to multiply both binomials, we will get back our polynomial 3ax minus 6ay plus bx minus 2by. Now somebody may be wondering, could we have rearranged just to group all the x's together and group all the y's together and get the same answer? No, let's test and see what happens. So if I'm to group all the terms with x together, so I have 3ax plus bx, and I would have minus 6ay minus 2by. Now, what is common to both 3ax and bx? We have x common to both, so we could factor out x. So then we will have what? 3 into 3ax, we're left with 3a, and x into bx, we're left with b. Now we have negative 6ay minus 2by. So in this example, we can factor out negative 2y, because negative 2 can go into negative 6, y can go into y, same thing here. So we're left with negative 2 into negative 6 goes positive 3, y into y goes one time, and we're left with our a, and then negative 2y into negative 2by gives us plus b. So ding 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 ding, we have a common binomial also. So hence our factors are going to be x minus 2y and 3a plus b. So yes, we could rearrange it, and we could have done that with question A. We could have rearranged that. We would have gotten the same solution. C. I think it's a bad habit. Every time I see C, I normally say it's 3. I don't know why, but who cares? Moving on. So we have 8px minus 8py minus 3qx plus 3qy. Now we see that what is common. We have 8p here, so, and we have 8p here. So them two you have what? Them two you have two common factors. Common factors of 8p. Over here, so we have negative 3q and negative 3 and positive 3q. So okay, we have 3q common to both. So we have some common factors. So let us factorize now and see what we get. So take out our 8p. So 8p into 8px, we're left with x minus 8p into 8py gives us y. Now what are we going to factor out here? We'll factor out negative. We always factor out the negative because we always want the first term in our binomial to be positive. So we factor out negative 3q. So negative 3q into negative 3qx leaves us with x. And negative 3 into negative 3 gives us a negative 1. And negative q into qy leaves us with y. So our factors are 8p minus 3q and x minus y. Those are our two factors. Now D. In this case, we could realize that one step of the factorization is already done for us. Why? How we know that? Because we already have a common binomial, and that common binomial is 5x minus 1. So we have one factor already, which is 5x minus 1. Hence, the other factor is going to be AB plus 3FG. Easy done. Easy, easy, easy. Why did we do this? We have a common binomial already. So one step was already being done for us. So our first easy factor that we could have seen easily was 5x minus 1. Now for the final question. We have 3x cubed plus 6x squared plus 4x plus 8. Now, what's the highest common factor in our first two terms? So we have 3, because that can go into both 3 and 6. And then the highest factor, the highest term that can go into x squared and x cubed is going to be x squared. Now let us observe our last two terms to ensure that they have common factors also before we go ahead and start. So we have 4x and we have 8x. And the highest number that can go into both 4x and 8 is 4. So we can go ahead and start factorizing by using the highest common factor. So 3 into 3 goes 1 times. X squared into x cubed leaves us with x. And remember, 1 times x is going to give us x. 3 into 6 goes 2 times. And x squared into x squared goes 1. 1 times 2 gives us 2. Plus 4 into 4x gives us x. And 4 into 8 goes 2 times. Hence, our factors are 3x squared plus 4 and x plus 2. And if I wrote it x plus 2 and 3x squared plus 4, they're still the same thing. So a quick recap of our steps. We're going to group terms with common factors, ensuring that the first two terms have a common factor and the last two terms have a common factor. For each pair, factor out the highest common factor. Final step, pause to check what was produced from step 2, ensuring that there's a common binomial factor. If not, rearrange and repeat steps 1 and 2. So thank you guys. Like, comment, subscribe, tell a friend about it, and I hope you guys start practicing for exams.